One morning, you wake up and his food is still sitting in the bowl. You search the house and eventually you find him isolating himself. He's hiding under a bed, avoiding eye contact. And the heaviest question of all, does my dog know what is happening to him? A 2021 study by philosopher Susanna Monso shifted how scientists view this moment. Humans are the only species that agonize over what happens after we stop existing. Dogs lack that specific reasoning. Instead, they feel immediate physical realities. They register that their bodies no longer respond the way they used to, that walks require too much effort, and that their appetite is gone. The visible shift into isolation marks a strategic conservation of energy. Your dog is responding to the internal feedback of failing systems by prioritizing the physical demands of their final hours. This diagram shows exactly how a dog processes chemical information. Scent molecules enter the nasal cavity and hit 300 million olfactory receptors. That network is so precise, dogs trained in California detected lung cancer on human breath with 99%. In ancient times, a sick or elderly animal would leave the pack to avoid slowing the group down and to draw away predators. They shut down external emotions to focus all their energy on fighting the illness. Some dogs do the exact opposite. Instead of hiding, they develop an intense, sudden clinginess, refusing to leave your side. While it looks entirely different, it comes from the exact same biological drive. Whether they pull away to protect the pack from predators or draw closer to seek safety from you, they are answering an ancient instinct. Both behaviors fulfill an ancient evolutionary mandate. These actions serve to protect the pack's integrity and signal their status to the protector they trust most. Near the very end, owners often witness a confusing pattern. After days of lethargy, the dog suddenly stands up. He eats dinner, walks to a favorite spot in the yard he hasn't visited in months, wags his tail, and appears completely normal for an hour. Shortly after, he passes away. Veterinarians call this the last rally. This brainwave chart illustrates the mechanics behind that final burst of energy. Research led by Jimo Borjigan at the University of Michigan revealed that when the brain loses oxygen during cardiac arrest, it does not simply slowly fade out. Instead, the posterior cortex produces a massive surge of organized gamma wave activity. As the physical system begins to shut down, the brain makes one final attempt to restore neural coherence and balance. That chemical spike forces a temporary state of high alertness. This fleeting burst of energy is an automatic neurological response. It provides the energy for your dog to eat one last treat, look at your face, and reaffirm their bond with you before their system finally powers down. For many owners, the end involves choosing euthanasia. It is a decision heavily loaded with guilt. However, the medical reality is that the injection simply acts as a switch, immediately turning off the brain and dropping the animal into a state where consciousness is erased. Look at this dual-axis chart tracking the biological response during the procedure. A 2015 UC Davis study led by Monica Ailman proved that a dog loses all brain activity about 52 seconds after the injection. Simultaneously, monitoring at the Free University in Berlin showed that stress markers remain completely flat throughout the entire process. The crucial question is what actually occupies their mind during those final 52 seconds of consciousness. For that answer, we turn to fMRI research conducted by Gregory Burns at Emory University. This fMRI scan shows how a dog's brain reacts to various stimuli. The glowing region is the caudate nucleus, the center for safety and reward. Burns discovered that this specific area activates at its highest possible intensity strictly in response to the scent of a familiar owner. It overrides food, other dogs, and external stimuli. During these final seconds of consciousness, the physical presence of a familiar owner dominates the brain's reward center. The neurological record shows that your scent and voice act as the primary stimulus, grounding the animal in a state of safety and reward. After they are gone, owners are left with a specific kind of silence. In 2016, a study in PLOS One found that 7.5% of grieving pet owners met all diagnostic criteria for prolonged grief disorder. Yet, society often dismisses this pain, telling you it's just a dog. Psychologists classify this exact phenomenon as disenfranchised grief, pain that your culture tells you is invalid. These side-by-side functional MRI scans dismantle social stigma. Researchers from Harvard and Mass General Hospital scanned the brains of mothers looking at photos of their children and then at photos of their dogs. The core emotional network, specifically the amygdala, lit up identically in both scenarios. This bond is physically etched into your biology over years of cohabitation. Your nervous systems began to mirror one another, with heart rate patterns and stress hormones rising and falling in tandem. You even developed a shared microbiome, literally exchanging gut bacteria through the environment you inhabit together. When that dog is gone, your body registers a physical loss of a biological partner it had spent years synchronizing with. The human attachment circuit does not verify the species of the companion. It only responds to the depth of the physical and emotional bond that was severed. When a dog passes, the resulting grief is your nervous system registering a massive deficit. It is the biologically accurate, proportional cost of having shared a synchronized life with a creature whose final neurological comfort was you.